Good afternoon, class. Thank you. You can sit down. Okay, today we'll be looking at the last section on loss of indices. And before we do that, we have to look at the homework that you were given during the previous lesson. So, I think we looked at the answer to A already, E, and L. Okay, so the answer for A was 11, the answer for E was a half, the answer for L was 4 on 9. Huh? Sorry, 4. Okay, letter B then. We start from Margaret.
Two.
2 is correct. Geno. C.
2.
2D. That should be cube root of 125. You just note that number 3 should not be in line with the square root sign. It should be at the top. Because if it's like that, then it means 3 times the square root of 125. Just make sure of that. That should be cube root of 125. Esther. 5 is correct. Letter E we did. Letter F, Rita.
Half.
A half. G, Daniel.
1/9.
G. Okay, F, it's not half. It should be 1/9. That was the answer for E. Okay, we looked at E already, so F is 1/9. Daniel, letter G. G.
1/10.
1/10. Siegfried, H. Cube root of 1/8.
A half.
A half. Boromeo, I.
1/10.
1/10. J, Natasha.
3.
3. Jake, letter K.
Half.
Are you sure it's a half? Is it a half?
2.
It's 2. Okay, it's 1/32 raised to the power of a negative power, so it's 2, not a half. L, Megan.
100,000.
Sorry, M.
100,000.
Okay, 100,000. N. Geronimo.
1/32.
1/32.
32.
Correct. Raylene. O.
2/3.
2/3. Agnes. P.
2/3.
Correct. Q. George.
4/9.
4/9. R. Gabriel.
8/27.
8/27. Letter S. Peter.
125/8 of 15 and 5/8.
125 over. Is it 8? Okay, 125 over 8 or
15 and 5/8.
15 and 5/8. Okay, I think that's all the questions. Is there any question you want me to do on the board? Please ask if you're having problems with them, especially the fractions raised to a power of a negative fraction. Letter J. Okay, letter J. 1 over 27 raised to the power of negative 1/3. Okay, 1 over 27 raised to the power of negative 1/3 is the reciprocal of 1 over 27 raised to the power of 1/3. Okay. What this one is asking now, if I remove that negative sign, then this means you have to find a number that you multiply by itself 3 times to give you 1 over 27. And the number that you multiply by itself 3 times to give you 1 over 27 will be 1/3. Not 3, 1/3, because 1/3 times 1/3 times 1/3 will give you 1 over 27. Which means if it's a negative sign, then it will have to be the reciprocal of that. So in other words, what you can see, the shortcut is the one I told you. You get the reciprocal of 1 over 27, which is 27. And you raise it to a power of not 3, 1/3. Which means you are looking for the cube root of 27, which is 3. Another way I showed you how to do this is to recognize that this means 1 over, so you can say 1 over 27 to the power of positive 1/3. And then say that the cube root of 1 over 27 is 1/3, and then multiply by 3 over 1, and the answer will be 3. Is it clear? Is there any other question? No? Okay. Let's see if I can get this. Okay, the last section on laws of indices. If a number A is raised to the power of m, and then it's multiplied by A, the same number, this time raised to a different power. The rule is that if you multiply numbers with the same base, Andrew, what do you do when you multiply numbers with the same base?
Add the indices.
Add the indices. So what would the answer to this be? It will be A to the power of m plus n. Okay, pond relay, what about A to the power of m divided by A to the power of n? This time you are dividing numbers with the same base.
You subtract the indices.
Okay, so what's the answer for this going to be?
A to the power of m minus n.
Okay, A to the power of m minus n. Rule number 3, I've got A to the power of m and then raised to the power of n. Kyle, your turn. What's the answer to this?
A to the power of mn.
A to the power of mn or A to the power of m times n. Okay, this one, rule number 4, A times B raised to the power of m. Solomon?
A multiplied by B to the power of m.
Okay, A multiplied by B to the power of m, or A to the power of m multiplied by B to the power of m. So in other words, if the indices are the same and the bases are different, you can multiply the bases and just have the indices like that, or you can multiply them out like that. Okay, this rule continues to this one. If you divide a over b to the power of m. We actually looked at some examples in the previous lesson. Then this will give a to the power of m over b to the power of m. Okay, examples. 2 to the power of 3 times 2 to the power of 5. If you were to evaluate leaving your answer with positive powers or with positive indices, what's the answer to example 1?
2 to the power of 8.
2 to the power of 8. Velma, 5 to the power of 8 divided by 5 cubed.
5 to the power of 5.
Good. 5 to the power of 5 to the power of 5. Where did I get 8 from? I added instead of subtracting, or I just put down 5 to the power of 8. Okay. 3. Chutaili?
4 to the power of 6.
4 to the power of 6. Make sure you are not saying 2 cubed. It's 2 times 3, so 4 to the power of 6. Okay, example number 4 here. 3 squared divided by 3 to the power of negative 1. Then
3.
3. Are you sure? She says 3. Anyone disagree with Dan? Yes? Megan, what's your answer to? Okay, we've got 3 to the power of 2 divided by 3 to the power of negative 1. Dan says 3. Megan, what's your answer?
3 to the power of 3.
3 to the power of 3. Okay, have a look at these two answers. Which one's correct? Hands up those people who think that it's 3. 1, 2, 3, 4, 5, 6. Only 6 people. You have to make a decision. Nobody stays on the fence. Huh? 6 people said 3. Hands up those who say 3 cubed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, plenty people sitting on the fence. You can't sit on the fence. Okay. What do you do when you divide? You subtract the indices. So this one is going to be 3 squared minus negative 1. So when it's 2 minus negative 1, it becomes plus, so 3 cubed. So 3 cubed is correct and not 3. Don't forget, you're subtracting and not adding. If you are saying 3 to the power of 1, then it's 3 times 3 to the power of negative 1, not division, because when you divide, you're supposed to subtract. Okay, number 5. Are you number 5 on the board? You only add or subtract the indices of those that have the same basis. Okay, there's no other 3 there, so I will have to subtract, because this is like saying 3 squared divided by 3 to the power of negative 4. So 2 minus negative 4 will give me 6. So 3 to the power of 6. 4 to the power of negative 1 and 4 cubed. Minus 1 minus 3 will give me negative 4. So 3 to the power of 6 times 4 to the power of negative 4. Minus 2 and minus 2, sorry, minus 2 and positive 2, you are again dividing. And then, so that means you have to subtract the indices. So minus 2 will give me negative 4. Okay, the question says, evaluate leaving your answers with positive indices only. I want someone to give me the answer to this question using positive powers only, or with positive powers only. Three to the power of 6 times 4 to the power of negative 4 times 5 to the power of negative 4. The answer with positive powers, anyone? And I want them with positive powers, not like evaluating 3 to the power of 6 and giving me an answer that's so huge. I want it with powers, not as whole numbers. Anyone? We have a go.
3 times 1 over times 256.
Where'd you get 256 from? You mean 4 to the power of 4?
Yeah.
Okay, I want the answers to be in powers only, not as a whole number like 256. I want them to be positive powers only. So 4 to the power of 4 times, is that all? 1 over,
5 to the power of 4.
should this be 3 to the power of 6?
Yeah.
Okay. 3 to the power of 6 times 1 over 4 to the power of 4 times 1 over 5 to the power of 4. Okay, note. Remember, a negative power means the reciprocal of, so 1 over. That's why we've got 1 over 4 to the power of 4 and 1 over 5 to the power of 4. But I can still write that again and say it's 3 to the power of 6 over 4 to the power of 4 multiplied by 5 to the power of 4. If you want 3 to the power of 6 following this rule, I can write this as 20 to the power of 4 because the indices are the same. Remember, when the indices are the same, I can multiply the bases. Okay. Example number 6. Where are we? Miriam. Just give us the answer, the first step of this question. 4 to the power of negative 2 over 5 raised to the power of negative 2.
Um, 4 to the power negative 4
Negative or positive?
and positive 4
Okay, minus 2 times minus 2 is positive 4. Over?
over 5 to the power negative 2.
Okay, 5 to the power of negative 2. Okay, again, there is a negative power there. Who can tell me the answer with positive powers? Anyone? Four to the power of 4. Rita.
Four to the power of 4 divided by 5 to the power, 1/5 to the power of 2.
Okay, if I divide by a fraction, just imagine this in your heads. 4 to the power of 4, she says divided by 1 over 5 squared. And that's, I'm dividing by a fraction. If I can rewrite that, what would it be? Siegfried?
4 to the power of 4 times 5 squared.
Okay, good. Times 5 squared. Because you are going to divide by, if I can just explain it here. 4 to the power of 4 divided by 1 over 5 squared. That's what that means. And this is 4 to the power of 4 multiplied by, this is a fraction. You invert and multiply by 5 squared over 1. So the answer will be 4 to the power of 4 times 5 squared. Clear? Okay. Now you are going to do questions 1 to 7. Yeah. Only if the indices are the same. That remains as 2 squared times 3 to the power of 4. Okay, these are the answers you should have. The first 7 questions, they're very easy. 2 to the power of 7 for 1. 2, 3 to the power of 3, 3 remains the same. You cannot multiply the bases and you cannot add the indices. 4, 5 to the power of 5. 5 also stays the same. 6, 5 to the power of 8 times 4 to the power of 5. 7, 10 to the power of 7 times 2 to the power of 7. You can also say 20 to the power of 7. Okay, next 6 questions. See if you can work quickly. Okay, question 8. Patrick. Where's the mic? Where's the mic? Where's the mic?
Two times 3 to the power of 6.
2 times 3 to the power of 6. Okay, correct. Number 9, Livingston.
9 cubed over 5 squared.
Okay, correct. 9 cubed over 5 squared. Kila, number 10.
4 to the power negative 1 times 3 to the power negative 4 times 2 to the power 7.
Okay, 2 to the, say that again, 2 to the power of
7
7
times,
times
3 to the power negative 4.
3 to the power of
yeah.
negative 4 times
4 to the power negative 1.
4 to the power of negative 1. Okay, can you put this as a negative or with negative powers?
No.
Why? You can. Lester, help your friend. 2 to the power of 7 times 3 to the power of negative 4 times 4 to the power of negative 1. With positive indices, please.
2 to the power of 7 over 3 to the power of 4 times 4.
Yeah, 4. Okay. Note, this is not wrong. Okay, but if you were asked, simplify without, evaluate leaving your answers with powers instead of positive powers, then this would be correct. But because it says, I think using positive indices only, yeah, using positive indices only, the answer is to be left in index form. This is the correct one. So make sure you learn that. The reason is when we do algebra, you are going to apply the same rules to algebra. But the thing with algebra is because they are not numbers, you cannot really simplify that much. Okay, so please make sure you understand what we are doing. Where are we? Number 10. 11, tau. Nine. Number 12, 10 cubed. And number 13, 8 to the power of 4. All right, your homework. You are to do questions 14 to 39. All the questions up to 39. I'd like you to have a lot of practice as much as you can, because when it comes to algebra, it becomes a little bit complicated, and we're going to, that's our next topic. All right, I'll have to let you go to your next class. So the key word to the pilot teacher is loss. So stand up. Good afternoon, class. Thank you.